we have y equals to 2x minus x squared, y is equal to 0, x is equal to 0, and x is equal to 1, and we try to rotate this about y-axis. As usual of our work, let us see what we are seeing here. What's the visualization look like? So the visualization is, first of all, if you plug in 0 here, if x is equal to 0, y is 0. When x is equal to 1, your y becomes 1. So just plug in some points to analyze the behavior of this object here. And then when x is equal to 2, you get another intersection with x-axis, which is just right here. So this is your parabola. Okay, now that you have your parabola, the rest of them are y equal to 0, which is basically your x-axis, nothing new. And then x equal to 0, which is your y-axis, and x is equal to 1. This is x equals to 1. So looking at the object, this is the object that we are selecting from left-hand side, not the right-hand side. The intersection between the parabola, the horizontal line, the vertical line, and this line here is this object. So you're trying to rotate this object about y-axis. So let us rotate this and try to analyze this as much as we can. The rotation of this object with respect to y-axis is basically taking this object and doing the rotation, full rotation here. So from the concept of finding the volume, what we can do, we can find the larger area and find the smaller area and do the subtraction, right? If you look at a cross section, this is the cross section that you have. So first, calculate the larger area, then calculate the smaller area, and then simplify as much as you can. But the larger area, if you forget about this curve down here, if you forget about your parabola, the larger area is basically here between 0 to 1, between 0 to 1. So here you have just, you have pi r of y squared, which is pi. But here, this is a fixed distance. Between 0 to 1, you have a fixed distance, which is just 1 unit. So you get 1 squared. Now you need to move on and calculate the smaller area. The smaller area is pi r of y squared. But what is r of y, right? You're trying to find the radius of the smaller one, right? The larger one was easy to work with. What about the smaller one? What is this guy? What is r of y down here that you raise it to the second power? This is the question that first we need to do a little bit of algebra to answer. We need to isolate our x on one side. So let me write it here. To find this question mark, which is r of y, we need to isolate x. So how do you isolate x? We're going back to algebra, to what we saw before. We know that y is equal to 2x minus x squared. So if you factor out negative sign, y becomes minus x squared minus 2x. But this is similar to what we saw before. This is similar to if you have a squared minus 2ab plus b squared is a minus b to the second power. We have two terms of it. So if we can add and subtract the third term, then we can write this in compact form. So y is equal to minus x squared minus 2x. I'm going to add 1 and at the same time subtract 1 to balance this. And then I'm using these three terms and following this formula. So y is equal to minus x minus 1 to the second power. And when you distribute negative sign here, you get plus 1. Why it is helpful? Because now I can subtract 1 from both sides. I get, let me just write it this way. So I don't have to remultiply. I'm going to bring this guy to one side and bring y to the other side. I get x minus 1 to the second power equals to 1 minus y, or x minus 1, which is the square root of 1 minus y. It results in x to be 1 plus square root of 1 minus y. This guy goes here. Very good. So we did all the algebra that is necessary to find the difference between these two areas and then put them inside the definite integral and do the calculation. So let us move on to next page and do the calculation. So the volume is equal to the definite integral 0 to 1 of pi times 1 minus pi times 1 plus square root of 1 minus y to the second power dy. Very good. You could factor out pi as well. So we get pi definite integral 0 to 1, 1 minus 1 plus square root of 1 minus y to the second power dy. So first write this in expanded form. The volume is the definite integral 0 to 1 of 1 minus, here you get 1 squared plus 2 times square root of 1 minus y plus square root of 1 minus y to the second power, which is 1 minus y, and then dy. So we try to simplify it as much as we can, and v is the definite integral 0 to 1, 1 minus 1 minus 2 times square root of 1 minus y minus 1 plus y dy. So obviously you can get rid of the opposite terms and you end up with this integral. You have 0 to 1, and let me don't forget to add pi. And here you have negative 2 square root of 1 minus y minus 1 plus y dy. Very good. So let us continue. Our volume is equal to pi integral 0 to 1. You could separate these, or for this guy, you can use u sub. It doesn't matter. But remember that. Let me just erase the integral and write down this guy here. The volume is pi. So the integral of negative 2 square root of 1 minus 2y is 2 times 1 divided by 3 halves 1 minus y to power 3 halves minus y plus y squared divided by 2, and y ranges between 0 to 1. So the volume is pi. You get 4/3, 1 minus y, 3/2, minus y plus y squared divided by 2 between 0 to 1. But plug in 1, make this guy to be 0. So far you have pi times 0 minus 1 plus a half, and then plug in 0, these two terms disappear. When you plug in 0, you get 4/3, so minus 4/3. And when we do the calculation, you get pi, and if you combine these two, you get negative a half minus 4/3, which gives us, let me make sure I did the calculation correctly. Okay, we took that one out, minus y plus y squared divided by 2. Okay, it should be negative. I forgot a negative sign here. Let me just fix that. Otherwise, we get a negative answer, which is not correct. Negative 4/3. Okay, perfect. So the answer is 5 pi/6.